Hi guys, sorry to be out again today. I really want to be there, but just like you're not supposed to come to school with a fever. Neither am I. So anyway, I wanted to do a quick video so that it's like I'm right there with you. Unit 2, which is what you're supposed to be going over today, function basics was what we worked on in that unit. So we had 4 major things: is something a function, function compositions, inverse functions, and transformation of functions. So I'm going to go through those real quickly with you here. As far as is it a function, we had 3 different representations. We had a function represented as a table or a list of ordered pairs. And the key question there is something a function? Was, do the x values repeat? If the x values repeat, then we don't have what we call a function. Remember, a function is something where if you input one thing, you output one thing. So if you have x values repeating, x's are our input, then you have one x outputting 2 different things, and that's not a reliable function. So cannot have repeating x values. How that shows up on a graph: if you have repeating x values, then your graph will fail the vertical line test. So you need to ask yourself, does my graph pass the vertical line test? And remember, that means that you take your pencil or your hand or a straight edge or whatever, and you run it along your graph, and if it touches this vertical line at more than one point at a time, it fails. Okay, and then we also looked at an equation to say, is this equation a function or not? Will it produce a function? And our key test there was, are there any even exponents on y? If y had an even exponent, this was our test when we were back in Unit 2, then it would not be a function, okay, if there was an even exponent on the y. All right, function compositions. I'm going to take a couple slides to go through this. Okay, so let's say we have f of x and g of x, and I've just made up 2 functions here. Function composition is where we take a function, let's say f of g of x, and we put one function inside another. If you look down at the bottom of the screen, I've shown that we could also do g of f of x. So what we're doing up at the top is we're putting g inside of f. Down at the bottom, we're putting f inside of g. Okay, so for g inside of f, we use the outer f function, 3x minus 7, as a framework. And the x we're going to leave open, and we are going to put g of x in it. See how right up here this said f of x, and it said 3 times x minus 7. Well, this says f of g of x, so it's going to be 3 times g of x minus 7. You see how that's g of x is x squared minus x? So f of g of x, it's 3 times g of x minus 7. Grouping is really important on these. Once you've done the composition, as we have here, we simplify by whatever math operations the expression is asking to be done. In this case, let's distribute, and we don't have any like terms or anything, so we're to our answer here. Now, if we're doing g of f of x, we're going to go back to the same 2 functions. We're going to use the 2 that are at the top of your screen. This time, this was g of x, and it was x squared minus x. Okay, so the g is our frame because it's on the outside. When I set up the frame, I put a blank wherever there was an x in the g function. So it was x squared minus x, so I have blank squared minus blank. Again, grouping is super important here. And then in the next line, we're actually going to put the f of x function, 3x minus 7, into those blanks. On my paper, I wouldn't, like if I were working this on my own, I wouldn't have this line. I would start with this line, and then I would fill in this part within the same line. I'm showing it to you in two separate lines so that you can see it separately, but it's up to you if you want to do it like that or not. So again, down here, I made the framework, x squared minus x, blank squared minus blank, and now we're putting the f of x, into the blank. And then we will simplify. Now the simplifying is the tricky part. I told you grouping was important. I'm going to kill two birds with one stone here. In Unit 4, you had to square a binomial. I want you to remember that to do that, you have to FOIL. It is not just 9x squared plus 49. That's not it. It is 9x squared minus 42x plus 49. Yes, you're seeing the next row. Don't worry about that right now. It's when you FOIL this, 9x squared minus 42x plus 49. Go ahead and FOIL it and make sure you agree with that. The other thing is you're subtracting this second one, and so you have to actually distribute your minus through this group. So it is minus 3x and plus 7. That's really important. Okay, then we combine our like terms to get 9x squared minus 45x plus 56. One more thing with function compositions. Sometimes we were not asked to just do f of g of x or g of f of x, but we were asked to do f of g of a number or g of f of a number. So what we did there was if we're asked to do f of g of -1, we actually do the g of -1, and we find that to be 2. Okay, be really careful here. You're going to have to make sure you group your -1 in your calculator, or your calculator is going to tell you it's 0. Make sure you're actually testing this, okay? But g of -1, you should get 2, and then you do f of 2, and that should be -1. Coincidence that we started with -1 and ended with -1. For g of f of 5, I want you to think through this process. G of f of 5, we're going to do f of 5 first. So think, what is 3 times 5 minus 7? Oops, I messed up, didn't I? It's not -8, +8. There we go. Okay, so g of 8, and then g of 8, my answer is going to be wrong, is 8 squared minus 8. And 8 squared minus 8 will not be 64. Or I'm sorry, will not be 72, but it will be 64 minus 8, or 56. Okay, that's function compositions. Two more things. Inverse functions. With inverse functions, we had to ask ourselves, we had to answer a couple questions. One was, are two functions actually inverses of each other? Okay, are they inverses of each other? And this was how we could tell. One, the graphs had to be symmetric over the line y equals x. Remember, that's your identity function. That would have, if you're thinking y equals mx plus b, it has a slope of 1 and a y-intercept of 0. So it goes through the origin, okay, it goes through the origin, and then it will have a slope of 1. So you'll be going up 1, right 1, up 1, right 1, okay? Must be symmetric over that. The ordered pairs have to be completely switched. The other way you can test it is with the compositions that we just talked about. If you have two functions, f and g, if you do f of g of x, if they really are inverses of each other, then that composition will simplify to be x, not 3x squared minus 3x minus 7. These are not inverses of each other, okay? Okay. And then actually, okay, one more thing. Notation for inverses. We put this little -1 superscript on there. That's not an exponent of -1. It's just indicating that we have the inverse. Okay? Reminding you of that. And then also how to find an inverse. Finding an inverse, we had a two-step process. Okay? Here was our two-step process. Remember what I just said about ordered pairs a minute ago? Talking about symmetric over the line y equals x. Every ordered pair is switched. Well, we switch the x's and the y's in an equation. Okay? This is finding an inverse function given an equation. Okay? We switch the x and the y, and then we solve the equation for y. Okay, we get that y by itself again. Once we do that, we need to put this notation on there, with that superscript -1 of x, saying it's the inverse of what we started with. Okay, one more thing. Transformations of functions. There are more than this. I'm just going to give you the heavy hitters right now, okay? And I'm giving you right now what you need, okay? Promise that. Transformation means that we're changing a basic parent function. It could be an absolute value function, that's that V shape. It could be a square root function where you have that point and it's curving out in one direction. Could be a quadratic function like we had in Unit 3. Any function, any basic function, these steps I'm going to talk about, they apply to all of them. Okay, so the first one is called a translation. A translation is also known as a slide. Okay? That means you're going to move but not change shape or direction. Translations always happen when we are adding or subtracting within or to a function. If you add or subtract outside the function, that means if you have absolute value, you take the absolute value of x, and either before it or after it, it will say +2 or -5 or something like that. Okay? If you add or subtract outside, it's always going to move vertically. And what we like about it is it always moves in the direction you would expect. If you add 2, shifts it up 2. If you subtract 5, shifts it down 5. It's exactly what you would expect. Add moves up, subtract moves down. Okay. If you go inside, and inside the absolute value, it says x minus 3 inside the absolute value. That actually probably moves the opposite of the way you would expect. Okay? What you do to figure out exactly where and how far it moves is you set the inside expression. I said the absolute value of x minus 3. You would set the x minus 3 inside equal to 0 and solve that. And then we have x equals 3. And so that tells you exactly it moves 3 positive units to the right. X minus 3 inside moves 3 positive units to the right. Okay, the other transformation that you may be held responsible for is reflections. And to reflect, that always involves multiplying by a -1. If you multiply by a -1 outside, it reflects vertically. I want you to see that connection. Adding or subtracting outside shifted vertically. Adding or multiplying by a -1 outside reflects vertically. That means over the x-axis. That's a vertical reflection. It does not change shape. It does not slide. It just reflects. Now, if you multiply by a -1 inside, it's going to reflect it horizontally over the y-axis. Okay. Whoops. I think that's all. Okay, so that's your basic Unit 2 review. You should be getting or already have a blank copy of the Unit 2 test. It may be the same form that you already had. It may be a different form. But you should be getting a blank copy along with the key. And so I want you to work through that and check your answers to the key to make sure that you're doing what you can. I am just hoping and praying that I'm going to be there tomorrow so that we can go through some more things. I'm going to make sure that I post a short tutorial for Unit 1 from yesterday, and I'm going to try to do Unit 3 for you today as well. Happy studying.